Meeting progress is recording. Okay. So I'm now host of the meeting. Look at me with all my power. Okay, so to start out, I'm gonna look at the two connections here. I don't know if this is gonna come through or not, but one of them has a black, or I'll call it gray band down the side of it. So a lot of times when there's two wires, one of them is going to be labeled with a band down the side of it. Okay, so for starters, I'm going to hook up the black. Oops. I'm going to hook up the black alligator clip to the one with the band, and I'm going to hook up the red alligator clip to the other one. And then, ooh, you can even hear it, huh? Check that out. Oh, that's nice. That's good stuff. So, okay, so it's going to spin, and just see if it's blowing air at you. Hopefully it's blowing air at you. Okay, so the current's flowing through that motor in one direction. Oh, I lost my, probably lost my picture if I didn't save it. Ooh, yeah, that fan totally dances off the table if you let it. Ow. And it kind of hurts. Okay. So let's do this. Let's do this. Let me grab, sorry for the mess here. I'm just opening up my drawing program again. With any luck, my little notations here. Not so much. We lost the series parallel, neither both notation. We had polarity. I'll draw that again after we get off the call, so you don't have to watch me draw it again. But what we had ended up with was a battery. Come on. A battery connected to our fan motor. Okay. And I said they're connected both in series and both in parallel, so they're going to have the same voltage and the same current. Right? So the current's going to flow that way. And the change in energy here and the direction of current through that component they're related by something called the passive sign convention. Okay, so the motor, both, so same voltage, same current. The passive sign convention tells us how the change in energy and the direction of current relate in passive elements. So passive elements, circuit elements, there's only a handful of them, but they don't add energy to the system. The system in this case is our circuit. Okay, so batteries are going to add energy, solar panels, generators, anything like that. It's going to add energy to the circuit. We wouldn't call that passive. We would call that active. The common passive elements, resistors, which we'll talk about more in detail tomorrow, capacitors, which we'll get to either tomorrow or Friday. Like I said, I'm giving you the quick and dirty overview of everything. Inductors, and let me see, let me get the chat up here again, in case you're talking to me. Can't read anything. Uh-oh, video's backwards. Hold on one second. I know why it's backwards. Because I changed the setting. How's that? Better? Okay. Oh boy. Having a day, aren't we? You know, I design technology. I've made a living around technology. There's some days where I just really don't want to use technology. Go outside, sit on the hammock, and read a good book. Anyhow, sorry about that. Okay, so passive circuit elements. Can't really work the fan. Uh-oh. Why not? Connect it to the battery. Yeah, if it's cloudy out, the battery's going to be your better bet. Okay. So passive circuit amounts don't add energy to the circuit. So resistors, capacitors, inductors, and I would say that the motor is kind of a subset of the inductor. Okay. There's another type of inductor that we can use that you're getting your electricity from the outside house. And battery's going to add energy, so that's going to be active. So motor, a transformer is going to change levels of AC voltage. So you have one on the power pole outside of your house somewhere. That's going to be a set of two inductors coupled together magnetically. Oh, got it. Okay, so these are our passive elements. There might be a few more, but these are the ones, the most common. So if you connected it this way first, and you believed me, because why wouldn't you believe me? Don't ever believe me. Experiment and do things your own way. Connected it this way, the current direction follows the passive sign convention. This motor, this is passive. This battery is active. And the current here is going to follow the passive sign convention. So let's define that. And we're good to wrap up after that. Passive sign convention. Okay, in the passive sign convention, we can state it one of two ways. The first way that it's talked about is current flows from high energy to low energy. High energy, and that energy is voltage. Oh, sweet, you ran it backwards. I was going to talk about that too, Casper. Yeah, you can, depends how much hot air you have in your lungs. I got plenty. So you can run it as a generator. And that's really all a big power plant is just a bigger version of that motor with something turning the motor the opposite way. Current flows from high energy to low energy. Yep, you got it. This is only true in passive elements, or it's only strictly true in passive elements. Okay, so that resistor, capacitor, the inductors, and the motor is really an inductor inside. It has a little resistance too. Okay, so that's the first way it gets talked about. So if we look at this passive element, the current through the motor is going down, right, as it moves clockwise. So it's moving from the high energy to the low energy, but only in passive elements. The other way that we talk, we state the passive sign convention is the positive current. This is behind my head now, isn't it? Enters the positive terminal. And when I say terminal, I just mean one end of the thing, right? Somewhere where that component ends. So the positive current, okay, is flowing this direction, and it's going into the terminal on top, which is the positive one. So you'll see it defined one of those two ways. I like to define it both ways. You get to pick which one you like and then stick with it. But if you read different textbooks, you'll see it stated differently. Okay, so I'm betting some of you have already done this, but what I want you to do now is flip the battery around. Okay, so swap the red and the black leads connected to the battery. My drawings are getting worse. That's how you know it's time to wrap things up, right? Okay, so we're going to put plus and minus there. These are still connected both in series and in parallel. Since they're in parallel, I can say that the plus is now on the bottom, the minus is now on the top. Okay, and looking at my passive sign convention, the current's going to flow from high energy to low energy. So current's going to flow that way. And as it flows that way, it's going to hook around and do that. Okay, so when you do that, the motor should behave differently. So let's see a model. So you want to see the physical stuff? Yep, it's going to spin the opposite way. Okay, where's my battery? Okay. I was trying to catch up and get as many photos of these setups as I could, but this one I don't have, so I'm sorry about that. So for now, I'm going to leave. Let me make myself big again. Okay. For now, I'm going to leave the red alligator clip. Come on, focus. The red alligator clip to the red wire, and the black alligator clip to the black wire. And where I'm going to make the change is on the other side. So bring this over. I had these two, and one of them had the gray stripe down the side, and I think I connected the black to that one, but now I'm going to connect the black to the one that doesn't have the gray stripe. Okay, and then I'll connect the red to this one. Okay, and now if I hold it this way, I'm not getting cool. If I hold it this way, I am. Okay. Smells like an old slot car. I can smell the ozone coming off the motor. It's a pretty cheap motor. So I don't know if you can smell that too. Okay, so if I want to fan myself now, I'm going to hold it the opposite way. These different alligators are the same ones as the battery. I don't think I can get this all on the camera at the same time. I'll try. Okay. That's the best I can do to get them all. Yeah, I'm pretty sure it's ozone. I remember, did you race slot cars as a kid, or is that like an old time thing? Video games got so much better. Ow. Just hurt myself with a fan. If you run a motor and it's a brushed motor, which tends to be cheaper, the arcing between the brush and what's called the commutator of the motor can create some ozone. So it's usually not a lot. It's probably not going to hurt you. But the old race cars on slots used to have brushes that touched the track to get the voltage, so the brushes would drag along the track, and you'd get a lot of ozone from those. So like if you were like having a really heated race, the whole room would smell like it. It brought me back to my childhood. So there you go. How you doing, Shams? Was it better when I held everything up? I'm going to get you more pictures tomorrow, I promise. Zoom. I can try. Take that down. Slide myself over. I don't think that's going to zoom. I think that's going to make it harder for me to get everything in there. Unless you meant zoom like race cars, which are way cooler. After these. Cool. Okay. All right. I hope you got a chance. Okay, so I think that's probably a good place to wrap up. I do want to get, nice, she got it to work. I love it. I love it. So you're persistent, and that's like the most important thing that you can be as an engineer. Have a little persistence. So, okay, so let's call that a day. I think the next part, so polarity matters. Really what I wanted you to walk away from that with is the direction of current flow is different. And let's throw the Death Star back on here so I'm not, oops. This is what I get for playing with my setup while I'm doing this. The direction of current flow changes depending on polarity. What I want to start with tomorrow, we'll do a little bit more with the solar lab, just to go over one or two more concepts that I think are important. And then we'll start to really play with the snap circuit kits. And while we're playing with the snap circuit kits, I don't just want to put them together and play with them. I want to put them together and then take our multimeter and look at the circuit and kind of take these concepts and see if we can't find them in the snap circuits. Nice, nice. Sounds like a good dad. And I'm saying that because I do that with my kids too. So hopefully we have a little fun with that. How do you get the blades off? I don't know. Did it come disconnected or did it come assembled? It's probably a press fit. This is usually, yoink 'em. Yep. This is usually where I call Professor Amaya and I'm like, I have a mechanical problem. And she takes care of it for me. But it looks like a press fit. But they also might be epoxied. So, I don't know. Be gentle. Okay. Any last questions? We're doing okay? Let me know what I can do. I'm going to get more pictures. I think that's going to help everybody. And let me know what I can do better for you. All right? Cool. Thank you, everybody. I'm really impressed with how much everybody's sticking with us and participating. I would have loved to meet all of you in person, and I hope that we get to someday soon, okay? But tomorrow, we'll be back here. All right? So take care, everybody.